This is Math 8, Section 1.2, the product and the quotient of powers. First, we are going to understand the product of powers property. Remember that product means multiplication. So we're going to be multiplying two things that both have powers. Now we've already learned that 10 with the base 10 to the power of 6 equals 10 times itself, 6 times 1, 2, 3, 4, 5, 6. We have also learned that 10 to the power of 9 is 10 multiplied times itself, 10 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times. Now what if we wanted to multiply these two numbers? 10 to the power of 6 times 10 to the power of 9. We want to find what that equals. Well, we could put this in parentheses for 10 sixths. 1, 2, 3, 4, 5, 6 times this in parentheses for 10 to the power of 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I believe I accidentally up here did 10 times instead of 9. Go ahead and cross one out. I apologize. We have 10 to the power of 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Moved here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Good. Now if we multiply these, we have 6 factors. Here we have 9 factors. What if we added those together? What would it equal? It would equal 15 factors. So we want to write out an expression here with 15 factors that would be equivalent to what it is up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 factors of 10. In total, this equals 10 to the power of 15, because 15 occurred twice. Now, what just happened here? We went from this to this. And now we have just one exponent for the whole expression. The bases, you'll notice, were the same, and so we can do this. We can add 10, or we can multiply 10 to the power of 6, 10 to the power of 9, by simply putting 10, 6 plus 9 at the top as our exponent. So you see 10, 6, with 10 to the exponent of 9, we just added them. So think product, when we're multiplying, we add exponents. Product for exponents, we add the exponents. And so you'll see 6 plus 9 equals 10, 15. Much shorter than writing out this whole process every time. All you have to do is add. Let's try another short example here. If we have a to the power of 4 times a to the power of 3, we could write it as a times a. 4 factors, 3 factors, or we could add them together and say 7 factors. 7 factors, written below, is 1, 2, 3, 4, 5, 6, 7. 7 factors is equal to this expression up here, which is equal to A7. Now we see A7 is equal to a to the 4th times a to the 3rd power. So we could write it as A4 times A3 equals A4 plus 3, which is equal to A7, the same as over here. And so you see this is a much quicker way to find it. Here is our basic algebraic expression. I want you to box this, highlight it. Very important to know, memorize this. AM plus AN equals AM plus N. Anytime that you need to add two things with the same base and different exponents, you could put, you can put the expression on top as A plus these two exponents. Now, let's try example number 7. In example number 7, let's start with A. Simplify each expression and write your answer in exponential notation. 3 to the power of 6 times 3. 3 simply written as this. You could also write as 3 to the power of 6 times 3 to the power of 1. So let's write this as 3, 6 plus 1 equals 3 to the power of 7. Pretty simple. Let's try B. Negative 4 to the power of 2 times negative 4 to the power of 4. We simply need to add the two exponents together. 2 plus 4 equals negative 4 to the power of 6. Let's try C. 1.2 to the power of 3 times 1.2 to the power of 4. We simply need to add together 3 plus 4 equals 1.2 to the power of 7. Go ahead and pause to try guided practice 1, 2, and 3. Let's do another example.
Sorry for disrupting.
Okay. That's 7th grade. They're having fun. Okay, example 8. In example 8, we will try A. So z squared times z6. If we want to figure this out, we do not have to know this number. It can simply be z as in algebraic, and we can still find it. It's z2 plus 6 equals z8, and that is our answer. Let's try B. We have negative b cubed times negative b to the 5th power. Notice that the negative remains inside the parentheses always. Negative b, 3 plus 5 equals negative b to the power of 8. Let's try C. In the parentheses, we have 2x3 times 2x. Now remember, if there's only 1 here, it's to the power of 1. So when we write it out, it's 2x, 3 plus 1. It's not 0, otherwise there would be nothing. It's 1, so there is 1. 3 plus 1, we get 2x to the power of 4. Go ahead and pause and try guided practices. 4, 5, and 6. Next section, use the product of powers property with algebraic expressions. Use the product of powers property with algebraic expressions. Not only can we do this when you have just one base, we can do it with multiple bases. So here is our example number 9. Let's try this together. A, b squared c cubed times b to the 5th power c to the 5th power. We can rewrite this as b squared times c cubed times b to the 5th power times c to the 5th power. Let's rearrange this so that the b's are together and the c's are together. B squared comes here, b to the 5th power comes here, c cubed comes here, c to the 5th power comes here. Now let us simplify by adding b 2 plus 5 times c 3 plus 5, which we get from these exponents, equals b 7 times c 8, which can also be written as b7 c8. And that is the answer for A. Let's try B. 2x 4y2 times 3x 2y6. First, let's rewrite the product. 2 times x4 times y2 times 3 times x2 times y6. Now let's regroup 2 and the 3 together because they're both numbers with no x and the x together, x4 times x squared. Now the y and the y together, y squared, y6. And now let's combine. I apologize, this is a 3. 2 times 3 is 6 times x4 plus 2 times y2 plus 6, which gives us 6x6 y8 as our answer for B. Go ahead and pause and try guided practice 7 and 8. Our next section, understand the quotient of powers property. Understand the quotient of powers property. You can see that how the exponents in 5, 5, and 5, 2 are related to the exponent in their quotient. We're going to see how they're related. Remember, quotient is divide. Here, as you can see when we did products, it was multiplication. Here we are dividing, therefore you can write it like this. In the same way, it can be written as a fraction. Either way you write it, these are the same thing. So we are going to be dividing. Let's go ahead and write this out as 5 with 5 factors on the top. 1, 2, 3, 4, 5. 2 factors on the bottom. 5, 5. And we see 5 factors over 2 factors. But we know, based on math and fractions, we can cancel. Cancel a 5, cancel a 5, cancel a 5, cancel a 5. We are left with 3 factors. The 3 factors that leaves us with are on the top, not the bottom. So we can write that as 5 times 5 times 5 over 1, which we can simplify to be 5 cubed. You can get rid of the 1 because it's on the bottom. 5 cubed because we have 3 5s on the top. Notice when we did this, our 5 is 5 minus 2. we use a minus sign, which makes sense because out of this 5 we took away 2, since there was 2 on the bottom to cancel, and that gives us 5 cubed, same as over here. Let's try another one. y7 divided by y4 could be written the same way as here. y7, y4, 1, 2, 3, 4, 5, 6, 7. On the bottom, 1, 2, 3, 4. 7 and 4. Now, 7 factors, 4 factors. Let's go ahead and cancel. Cancel 1, 2, 3, 4. We have 3 left, which can be written as y, 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 oh, y. 1 on the bottom, that can be written as y cubed. Same as up here, what we did was it looks like y7, the first one, minus 4. 7 minus 4 is 3, so it's y cubed, just like you could see at the top. And here is our example of that. Now this is the important thing I want you to note. You have this rule for when you multiplied. I'm sorry, I put a plus there. Go ahead and turn that into multiplication. This one is also very, very, very important. Box it, star it. It is AM divided by AN equals AM over AN equals AM minus N. In this expression, A cannot equal 0. This is very, very important. Very important. Now let's try an example. Let's try example number 10. A. Simplify each expression, write your answer in exponential notation. 9 divided by 2 to the power of 6. We know if it's divided by, we can write it as 9 minus 6. 9 minus 6, which equals 2 to the power of 3. B, negative 7, 5, divided by negative 7. Remember, negative 7 has an implied 1, which means it will be negative 7. 5 minus 1, which equals negative 7, 4. Let's try C. 3.5 to the power of 8 divided by 3.5 to the power of 6 equals 3.5. 8 minus 6 equals 3.5 to the power of 2. We can see how this works out. Go ahead and try guided practice 9, 10, and 11. Almost done. Last example of the day. Let's do A. We are going to be using the quotient to divide algebraic expressions. Up here you saw numbers. Down here we're going to be seeing letters. It works exactly the same way as long as the letter is the same. y8 divided by y2 equals y8 minus 2 equals y6. B, negative x with 6 as the power divided by negative x with 2 as the power equals negative x. Notice we're still keeping this inside. Negative x, 6 minus 2 equals negative x to the power of 4, and that is our answer. Go ahead and try guided practice 12 and 13. That is all you have for today. Make sure that you come with any questions, and we will see you in class tomorrow.